Let's look through the next unit, and it's about application, usage, and maintenance. Okay. So the objective here is just to look more carefully at the different measuring tools here and what it looks like to take these measures using the tools of the steel rule and the caliper and the measuring tape. One thing with the steel rule here that they mention is that you don't want to rely on using the edge of the ruler always for a couple reasons. The first major reason is because, like it says right here, due to it getting damaged from misuse, true measure might not be as possible. So obviously, if it's in great shape, it doesn't really matter. But just to point that out, that's one of the major reasons why they would say that it's better to measure between two graduation lines rather than from the end of the rule. What they mean by that is that if I'm going to use this as an example, they would say that it is better to, let's say, start right at 1 inch and measure in between 1 inch and 2 inches rather than trying to use the edge, because the edge could be damaged if we're talking about after years of use. And so that's why they call this correct use between graduations. So in this case here, they're measuring in between, starting at the 1 inch and they're working their way up. So here you would just have to do a little bit of math, and the measure here looks like it's, 4 inches and maybe 16 out of 32, maybe 4.5 inches. It looks like it's 4.5 inches, but really, since it started at one, it goes from 1 to 4.5. You would need to subtract that, so that way the measure really is 3.5. It's not 4.5. The reason why is because we didn't use the whole first inch of the tool to measure. So they would consider this an incorrect use of the ruler because you're starting it right at the edge. Now, there are some exceptions, like they say, if you're going to do it, if it has a hard stop right here at the end, now you've got a built in support. Because besides the fact that this could be dinged up, the other reason is that it's possible that you don't line it up quite correctly. So if you had a hard stop here, you could use the very edge of the ruler. The another observation here in the reading here, it says that when measuring length, the rule must be kept in a straight line parallel to the center line of the work. If it's not in a straight line or parallel, the measurement will be longer than the actual piece should be. So, for instance, if I'm looking at this, I mean, obviously, I think you guys kind of know that you would not angle your ruler up, but there are times where if you don't hold the ruler quite straight, you might end up with what they call a not parallel measure. And so if the measurement is not parallel, not perfectly lined up, then you're going to end up going, um, off center. So for instance, let's say my starting point is right here, and I'm trying to measure the distance between that and this object here. Let's say we just got a nice little smiley face. And I wanted to use a ruler to measure from this starting point over to there, and I'm trying to measure the length. If my ruler is perfectly straight, it's going to give me a more accurate measure. But if my line is not parallel and I have to angle it, then it's going to take longer to get there. I know this isn't the best example, but you kind of get what I mean here. Is that if it's not parallel, you're going to get an incorrect measure that ends up longer than it really is. Because as this thing is tilted up, you can see that the measure is going to end up being a little bit longer than that block really truly is. There's this other thing that is called parallax, and this factor of parallax is simply this: it's just an observation error. So if you're reading this incorrectly, and depending on the thickness of the ruler or how you hold it, but it's really just an observation error. So that's what parallax is. It is on the test. If you just know that parallax means observation error, then you'll be in good shape. Here are just some examples to look at here about some of the graduations that exist. So here, if it was a tenth of an inch, we can see here that this graduation is broken up into tenths. So we've got a tenth, 2 tenths, 3 tenths, 4, 5 tenths. But instead of saying 5 tenths, we should be reducing the fraction to say 1/2. Same thing with 6 tenths. Instead of 6 tenths, that should be reduced to 3 fifths. So math does come into play on this test. We just want to make sure you are prepared and aware of that. Down here, we've got 16 is what the graduation is split up into. So I've got 1/16, 2/16, but you can see right here, this arrow 2/16 is really 1/8 because you have to reduce it. 3/16, 4/16 is not really 4/16. You need to reduce it to be 1/4. And then 5, 6, 7, 8/16 is really reduced over to 1/2. So make sure when you're going through this process that you are remembering to reduce your fractions. And these are just some more examples of other graduations that exist on different kinds of rules. Here's 32, for example. So another thing to notice, I mean, if you use rulers and things like that, you kind of notice that the lines are not all the same. Sometimes they're staggered, meaning that we're going shorter, a little bit longer, shorter, a little bit longer, and so on and so forth. And then you get to these other marks that are even longer. So right here on the 32, I've got, let's just call this like level 1 in terms of length. These ones are level 2 in terms of length. This one is even higher, level 3. And then this one is the highest, which is, we'll just call it level 4. These are just made up terms here for me, but my point is that there's different heights on these lines of staggered. So once you use these tools a lot, that'll stand out. Up here for the eighths, there's only 3 of them here. So we've got the longest one, which would be like the 4 inch mark. And then I've got an eighth, an eighth, an eighth, an eighth, an eighth, an eighth. And then the halfway mark is a little bit longer. That's usually how most of these rules go. The halfway point would be longer. So right here, this tallest line represents a half an inch in between the 4 and the 5. So those are the staggered lines that help you see this more clearly. Here are some metric examples here. We've got our half millimeter separation right here. And then we've got a full millimeter up top, it looks like. So when you're looking at just that first little line, as it says here, this is just a half millimeter. Each one of these lines are only a half millimeter. So you want to pay very careful attention to that. If you had something going on there, the staggered lines look a little different. We've got the half millimeter is the shortest, 1 millimeter is the next staggered up, 5 millimeters is next, and then 10 millimeters is the highest amount. 10 millimeters equals 1 centimeter. And that's the highest line that we see here. This here is just a little section about converting fractions to decimals. And you do that with division, whether that's with your calculator or with old school pencil and paper. There are some times where we see these measurements broken down into fractions, other times it will be with decimals. Reading the tape on the tape measure, there are some little details here that I want to point out. As you notice when you look on this first little indicator here is going to tell you the length of the tape, and we know that it's 5 meters 16 feet. While you can't see it on here yet, here's an example of over here of, you can see right in between 2 and 3 feet there is that black diamond up top. That refers to, this is for people who are working on construction sites, putting together um, buildings and walls and things like that that are going to require lots of studs and measurements and trusses to help build this frame and this wall. Well, they have these markers there for a reason. The the diamond symbol, like it says here, is going to be what we saw up here, right there in between 2 feet and 3 feet at the top. And this refers to something at that occurs at 19 and 3/16 inch. And so there'll be a little diamond symbol. And this is used for engineers and construction people as they look at the wood floor trusses. So this is just the diamond that measures that off. There's also at a 16 inch, there's a little triangle on your tape measures that they gave us, and those also have to do with a specific measure that helps someone working and to know the distance apart for studs in a wall that help secure that wall. Right here, we just kind of see an example of how someone would use a caliper to line up the legs and the points to touching the part there for measurement. Then you would take that out. This is an example of the one below here is an example of an inside caliper that measures the inside of the part or piece. And then after you are done with that part, you would need to pull the caliper um, over to here and line it up with the steel rule. And that is what they call transferring the measurement. So I've lined up the points of the caliper, and then when I lay it on this steel rule, that's what they call transferring the measurement. Here we've got care, maintenance, storage, and for the steel rule, we want to treat it gently. Don't mix it up with different kinds of tools in a toolbox that will give it dings and bends and scratches and things like that. The tape measure has got its own built-in protection once the tape is inside, but you still want to be careful when we are using it to not pull it beyond its limits, and to be careful when we are pulling it out and retracting it. The caliper, we want to close it correctly. Don't over close it where the points are gonna overlap and bend.